Hello friends, I am Surya Saxena. Today I will demonstrate the concept of linked list. This is the outline of today's lecture. Introduction, what is linked list, representation, applications, why we use linked list, and finally we will implement a node in C. What is a linked list? Linked list is a linear data structure and is the very common type of data structure which consists of a group of nodes. We can see the position of linked list in this classification of data structure, that is linked list is a linear type of data structure. What is linked list? A linked list is the collection of nodes with various fields. Normally it divided into two fields only. That is, first is information field which contains the data itself, and second is the link field which has the address of the next node. How we represent linked list? So this is an example, real life example of representing a linked list. See the information and address part over there. As we can define, a train is a combination of different coaches, and if I replace coaches to nodes, so I can define a train as a group of nodes, while the first arrow indicates the information part of the first node and second arrow indicates the link part of the first node, which contains the link or which join first node to the next node. This is again the representation of linked list. Following is the linked list of having three nodes. We will discuss header later on. Linked list representation. So as per the above illustration, we can define, or we must be define the terminology of linked list. First of all, node will appear. So every data item in linked list is called a node, and every node is usually divided into two parts. First is information field and next is the next field or pointer field. So linked list contain a pointer variable called start to start the node, or as our engine start the linked list or the train. In the same scenario, start holds the address of the first node, that is indicating the starting or the first node of our linked list. And where the linked list ends, it is ends over here in the last point. You can see last node carries link as null, because from the last node itself there will be no preceding node in linked list. So pointer field of the last node must contain null, which indicates that linked list it end over here. A proper representation of linked list is this. For example, you can see the second node, the first arrow indicates information field of second node, and the next arrow represents the next pointer field of the second node, which contains the address of the next node having the data as 1202. Now, applications of linked list. Linked lists are preferred when we don't know the volume of the data or how much data we will wanna do stored, or it is also used to implement other data structure as graphs, trees, queues, etc. It is also used in compiler designing, implementing different file structures, Google search algorithm, creating hyperlinks. It is used in the hash table, for example in separate chaining method of hash table. It is also used to implement various computer games also. So this is the graphical representation of singly linked list. In this particular video, we will discuss only about the singly linked list and the other types of linked list. For example, doubly linked list, circular linked list, double circular and header. I will discuss all of them in my following videos also. So now only concentrating on the singly linked list. So this is the proper representation or graphical representation of singly linked list. First or start or head contains the address of the first node, that is 4000. So 4000 is the address of the first node. This node is divided into two fields, that is first is the data field that captures 10 as an integer type of value, and second contains 1000, that is the address of the next node. Same scenario will repeat with respect to the second node, and when we'll come to the third node, that is the last node of our this particular linked list. So the linked list which so the node of the linked list which is having its address as 2000, it contains 20 in its data field and null, very importantly null, in its pointer field, because it indicates that no more node is further remaining in the linked list, or it indicates the linked list is end over here. This is the representation of singly linked list. We are constructing a structure type of node because they are different type of data structure what we wanted to store. First is integer type of information and pointer type of link. Now at last we will define the structure node as a star node or a pointer node. So in our totally program, when we use a node, the node will give this proper structure to us. Okay. This is the representation of a node in a C and C++. We can use same scenario as I discussed earlier with the concept of classes also in C++. Nothing more change on that, but the output will remain same. Why we use linked list, or the question is arises over here. So from the above description we can say that there were the various problems with respect to the implementation of different type of data structure by using arrays or static memory allocation. For example, size was fixed was there, insufficient utilization of memory because we cannot append or shrink the memory size of the memory while using the array or static memory allocation. And linked list is an example of dynamic memory allocation because memory is allocated at the dynamic time or run time. So operations at any particular position were complex there with respect to the arrays. So now we can say that now linked list is a solution of all these problems, or we can say that because to get rid of these all the problems we use a dynamic memory allocation technique, and linked list is an example of that dynamic memory allocation technique. Now this is the source code that will facilitate you to give a proper demonstration of the linked list of a node in C. So we will discuss this also by using our C or C++ editor itself. Give me a fraction of second also. Mm, yeah, now this is going to be happen implementation. Now, first of all, I have included the header files, standard input output, conio and malloc for the dynamic memory allocation. This is again the repetition of our earlier discussed scenario, that is struct node, integer type of data over there, and pointer type of next field is over there. These are the pointer variables. Start to start the node or start the linked list, and head is the name of our first node, and temp is a temporary variable. In this particular program we will not use this temp, and in my further videos we will use this temp also. So this is the starting of main function. Then after that clear out the screens, and what we are going to do, I have mentioned this, that we are going to creating the first node. So enter data value in the first node. Remind this, the first node data enters only the data field of the first node itself. Now this is the important line. The head is the name of our first node, while what we are creating, that is the first node, and head is the name of our first node. So head equal to struct node. What we have, struct node over there, yes, struct node over here, that is the pointer type, and malloc means memory allocation, dynamically memory allocation, and size of head. So this particular line will give a size of a particular node, that name is head, dynamically memory allocation for this head node. So this is called the runtime memory allocation, and this is the beauty of the linked list. Now we are taking the values in the data field of that head. Remind that head's data field value will be entered by the user, and head's next field or field will capture the null, because this is the very first node of our linked list, and because this is the very first node, so its next pointer field should contain null, because no more nodes will continue to this also. And start, that was the engine of our train. So start should point to the head, or start should head the address of the head. So the address of the head is assigning to the start variable. Okay. So now at the final, we will printing the data which is captured or we have entered by the user in the head data field, and hold down the screen. Now see the output. enter the data value in the first node. For example, I have entered 12, so the output is in front of you. It is a very nice. The first node of linked list is 12. So this is the proper demonstration of the implementing node in a C of C or C++. So I think this is all for today. We will meet later on. Thank you for watching.